Hello everyone, welcome to the AMATS Club. This is Dr. Zheng. Today, we'll go through an important technique in quadratic functions known as completing the square. Let's get started. First, we will begin with the concept of square numbers. Let's take a look at a simple square. A square has 4 sides, each with the same length. If you put an integer on each side of the square, the numbers multiply together to form a perfect square number. Examples are 4, 9, and 16. Non-perfect square numbers can be comprised of a perfect square number plus an adjustment. The same concept can be applied in quadratics. Just like for integers, any quadratic can be comprised of a perfect square quadratic plus an adjustment. Take another instance of a square. A perfect square quadratic can be expressed by multiplying x times 2, which will give you x squared plus 4x plus 4. So the goal of completing the square is to switch from the expanded form ax squared plus bx plus c to a perfect square form plus an adjusted value. Now, let's take a look at the completed square form of a quadratic equation. The vertex, or a completed square form of a quadratic, is given by a perfect square plus and minus a constant. This can be expressed in the standard quadratic form ax squared plus bx plus c. You don't have to memorize this, but it helps to understand where this comes from. Next, we shall talk about the axis of symmetry. An axis of symmetry is a line that splits a parabola to form mirror images. Let's take a look at the simplest example, y equals to x squared. So the axis of symmetry will occur at x equals to 0. What happens when y equals to x plus 1 squared? If you can see, the axis of symmetry that occurs at a point whereby the parabola meets a certain line. In this case, the simplest case, it meets at the y equals to 0. So let's say if you set y equals to 0 and you have x plus 1 square and you simplify it, what you get is x equals to minus 1. If you plot this on the graph, this axis of symmetry will occur at x equals to minus 1. Similarly, if you have for any equation involving y equals to x plus g, the parabola will give you an axis of symmetry and x equals to minus g. And this happens, the parabola will shift to the left if g is a positive number, and it will shift to the right if g is a negative number. Next, let's talk about y minus g is equals to minus b over 2a. This is rather simple. If you look at the coefficient that matches b, the coefficient of x and itself, you'll find that 2ag will be equals to b, g will be equals to b over 2a, and minus g will be equals to minus b over 2a. So that's pretty simple. Lastly, we shall take a look at why the vertex is minus g h. So let's go back to the simple example of y equals to x squared. We have previously established that the vertex of y equals to x occurs at 0, 0. So what happens when you increase the adjustment by 1? If you sketch the graph of this, you'll realize that y equals to x squared plus 1 has a vertex of 0, 1. Similarly, if you have y equals to x squared plus h, and you sketch the parabola, you will find that the vertex will be equals to 0, h. And the parabola goes up when h is positive, and it will go down if h is negative. Next, let's go through the completing the square method. We will go through the method first and then explain why it works. The goal here is to rearrange from a standard quadratic form into a perfect square plus or minus a constant. The example we're going to use is y equals to 2x squared plus 8x plus 3. First, we factor out the coefficient, from the terms with x, which is this and this. So we factor this out. Next, we halve the coefficient of the x within the brackets and then square it. Take this, halve it, and then we square. So we take this value, we do a plus 4 and minus 4 inside a bracket, which can be done. The value of y do not change because plus 4 and minus 4 makes 0. But now you notice that this expression here forms a perfect square and can be compressed down to this. The final step is to simplify everything that is outside the perfect square, so that to give you the adjustment number, minus 5. And from this, you will be able to tell that the vertex will be minus g h, which corresponds to minus 2 and minus 5. If you plot it on the graph, it will look like this. Why does this work? Or how does this work? Suppose you have x plus g, which is a perfect square. I need to expand it. X squared plus 2gx plus g squared. And you compare the coefficient of the x with this 4 over here. Now, 2g will be equals to 4, g will be equals to 2, and g squared will be equals to 4. You notice that this g squared 4 corresponds exactly to what you have over here. It is no coincidence, because you notice that this g here is 2. And therefore, you can compress all these together to form the perfect square. Next, let's take a look at an example of completing the square application. The thorn ball's height is given by the expression h equals to minus 5t squared plus 20t plus 3. Find its maximum height in meters and the time it occurs in seconds. If you look at the horizontal axis, it will be given by t in seconds, and the vertical axis given by h in meters. This is a classic or standard completing the square application question. The first step is you take out the 5 from every single variable with t. And once you factorize out the 5, you end up with this expression within the brackets. Next, you take the coefficient of t, which is given by minus 4. You halve it. That gives you minus 2. And then square it to give you 4. Next, you do plus 4 and minus 4 within the brackets in order to derive the perfect square expression within the brackets. Compress it down, turn it to t minus 2 bracket square, and simplify the terms on the outside. That would give you plus 23 adjustment. As we mentioned previously, the vertex of a completed square form is given by minus g and h. And therefore, in this case, minus g would be 2 and h would be 23. Okay? So how do we know? So we know that this is the vertex. How do we know that this is the maximum or minimum point? All we have to do is to look at the sign on the t-square. If it's a negative sign, it will have a frowny face. And if it's a positive sign, it will have a happy face. So this is a negative sign. We have a frowny face, and this would be the vertex. And this is the maximum point. Okay? And since this is not the x or the y-axis, it's a t and the h-axis, the maximum point occurs at 223. These two will correspond to time equals to 2 seconds, and the 23 will correspond to the height in 23 meters. So there you go. The maximum height occurs when t equals to 2 seconds and h max equals to 23 meters. That's all for today. I hope this lesson has been useful in explaining the rationale behind completing the square. If you are a Singaporean student taking additional mathematics and are worried about the steep learning curve, the AMAS Club has a program specifically designed to explain each concept clearly and help you remember it. For more information, please visit our website through the link below. To get updates on more videos like this, please remember to like and subscribe. Thank you and have a nice day.